Welcome to the session 5 of Unit 2. We are still looking at tools of economic analysis. Now we are going to talk about simultaneous linear equations. In our study of price theory, we may not only be confronted with the analysis of single commodity market, but also the multi-commodity analysis. In a two commodity market, for instance, we will be able to deal with two prices of commodities, and that is our analysis will involve the solution of linear equations in two variables simultaneously. That is why in this session we want to consider solution to simultaneous equations. Here we are going to talk about how to solve simultaneous equation by different methods. Our main focus by the end of the session is that you should be able to find the solution of a simultaneous linear equation using the method of elimination. The reason is by using method of elimination, you easily solve the equations. Although we have other method, we have the substitution, and we also have the graphical method. It is mostly easy when you solve by elimination method. So that is why we want you to be able to find the solution to linear equations simultaneously by using the method of elimination. Now let's consider the equations below. Now take note of this. Remember, note that the equations here are two, and the variables here are also two, x and y. In simultaneous equation, the number of equations, let me say, number of variables depicts number of equations they will give you. So when they give you two variables, they will actually give you two equations. When they give you three variables, they'll give you three equations. When they give you four variables, they'll give you four equations, and the likes. It goes on like that to solve. So in this case, we see we've been given only two equations and then two variables. Now we can solve these two variables using this equation simultaneously. A solution to this particular system of equation means a pair of values for x and y which satisfy this equation simultaneously. So we want to get a value of y and value of x that when we put in, it will indeed be equal to what? 16. And this one, we'll get value of y, value of x. When we put in, we'll get what? 7. That is what we mean by satisfy the equation simultaneously. Now, alternative procedures can be adopted to obtain solution to simultaneous equations. Now, these procedures, as I said, is one method of elimination, method of substitution, and the graphical method. But here we only want to consider the method of elimination and substitution. Let's get started. We can actually find values of x and y in pair of simultaneous equations like the one we gave. First, we can find equivalent system. Let's recall the equation they give us. We had y minus 3x equal to what? 16, equation 1. And they gave us 2y minus x equal to what? 72 as what? Equation 2. Now, by elimination method, what we mean is that we'll try and then get rid of one of the variables, either y or x, in this equation or any of the equations, and then we can easily find the value for the other. Now, and in doing so, we manipulate the coefficients. So we can manipulate the coefficient. So let's look at this. The coefficient of y here is 1, but the coefficient of y here is 2. The coefficient of x here is only minus 1. So how do I get rid or eliminate one using these equations? Now I can say multiply equation 1, we multiply it by 2. Now with the elimination, when we multiply, we can multiply or divide an equation by a particular scalar, then we add, alright, the resulting equation. So I can say multiply equation 1 by 2. Here I'll get 2y minus 6x, then 16 times 3. What answer will I get for 16 times 3? So you can point that on your calculator. 3 times 16, I'll get 48. This can be like equation 3. Then I can say that subtract equation 3 from equation 2. So I can say equation 2 minus equation 3. So that I'll have 2y. I'll write my equation 2 minus x equal to 72. Then minus here, my equation 3 is now 2y minus 6x equal to what? 48. I'll close it. Then I'll do my calculation. Now, 2y minus 2, I'll get 0. minus x minus 6x. Minus 6x gives me positive. So minus x plus 6x. What will I get? I'll end up getting 5x. It's like you owe one orange, then you go and settle with 6. It means that they will have to balance you with what? 5. Now 72 minus 48, what will I get? I'll get 24. Now in this case, I'm going to get equal to 24. I'll make x the subject. It will be 24 divided by 5. 24 divided by 5. Wait, I think there is a mistake somewhere. Now 16 was supposed to multiply by 2, not 3. So it means that here should change to 32. Alright. Thank you. I think because I realized that I wanted to get a whole number of my equation. I was thinking my equation was wrong, but the equation was not wrong, but the solution rather. So 32. So 2y minus 2y 0 minus x plus 6x, I'll get it's like 6 minus 1, which gives me 5. So I have 72 minus 32, which gives me 40. Yes, 5x. Now I have 5x equal to 40. Divide both sides by 5. 40 divided by 5, I'll get x is equal to 8. So now you see that we were able to eliminate y from this, and we concentrated only on the x, and we found x to be 8. Now having found x to be 8, I can put it in any of the equations. I would rather want to put it here so that I won't go and multiply it by anything. So I'll have 2y minus 8 is equal to what? 72. Now I have 2y is equal to 72 plus 8. And I have 2y which will be equal to 72 plus 8 gives me 80. I divide both sides by 2. Now 80 divided by 2, I'll have y 40. This we could have done it otherwise. We could have multiplied equation 2 rather also by 3. Assuming we multiply equation 2 by 3. Now we are going to get 6y minus 3x. Then 72 times 3 will get 216. This can be say this one also equation 3. Now when I make it equation 3, I can now say equation minus equation. Which equation will I use? So equation 1, right? Because we multiplied equation 2 by 3, we are now going to deal with equation 1. So when I do so, I'm going to get something like 6y minus 3x equal to 216 minus, I'll put it in bracket, minus y minus 3x equal to 16, bracket close. Now 6y minus y, I get 5y minus 3x minus 3x. Minus 3x gives me positive. So I have minus 3x plus 3x, I'll get 0. I can say 0. Then 216 minus 16 would what? 200. Now here you see that we eliminated, so we have equal to what? 200. Divide both sides by 5, get y to what? 40. Now I can easily put y equal to 40 into equation 1 here. When y is equal to 40, I'll have 40 minus 3x equal to 16. I'll bring the 3x here and the 16 here. So I'll have 40 minus 16 equal to 3x. Now I have 40 minus 16. What do I get? I'm going to have 24. 24 equal to 3x. When I divide both sides by 3, I'm going to have x equal to what? 8. So you see we have the same values. We have the same values. Let's try and use the substitution method. Then we will leave you to choose which of the methods you are okay with, whether you always want to solve by substitution or you would prefer the elimination. But the elimination is a bit simple. The substitution may not always be easy to solve. It may appear easy sometimes, but it is not always easy. So maybe what you can do is when the equations seem easy to solve by substitution, then you go by substitution. When you are finding it difficult to get factors to multiply a particular equation to add or subtract to the other equation to eliminate, you can easily go by the substitution. But when the substitution also becomes very, very tedious, or the equation you are going to have for the substitution is very, very complex, then you have to advise yourself and stay with elimination. So with this same question, we will apply solving by substitution. I'm trying to clean my board. So let's solve by substitution and see what was the equation. Now we have y minus 3x is equal to 16, equation 1. Equation 2 was 2y minus x equal to 72. Alright, equation 2. Now with the substitution, what we do is that we try to make one of the variables a subject. So here I can say from equation 1, I want to make y the subject. So y will be equal to 16 plus what? 3x. I can name this equation 3. Now I'll come and say put equation 3 into the other equation that was left, alone. So put it in equation 2. So wherever I see y, I'll put 16 plus 3x there. So here I have 2, then 16 plus 3x minus x equal to what? 72. I'll expand, I'll have 32, 2 times 3, I'll have 6x, and minus x equal to what? 72. I'll have 32 plus 5x equal to what? 72. I'll group like terms, I'll have my 5x remaining, 72 minus 32. Forgive my 3. I'll have 72 minus 32 will give me what? 40. I'll now divide both sides by 5. 5 goes into 48 times. I'll now come and say that it implies that x is equal to what? 8. Now when I have x is equal to 8, I can easily put it into equation 2. I can say put x is equal to 8 into equation 2. So I'll say 2y minus 8 is equal to what? 72. Let me bring a line and dash here. So that I have 2y equal to 72 plus 8. Then I have 2y equal to 80. Divide both sides by 2. I have y is equal to 40. As simple as that. The decision is yours. Either you go by substitution or you go by elimination. But it's not always that substitution will be easy like it is here. So you can be solving different questions to know which one of them you can use at fast rate. See you in the next session. That is the last session for this unit session. Session talks about economic data.